Welcome to datascience.show, the podcast where data science meets executive leadership. We talk with top AI and analytics thought leaders about turning data into real business impact. If you're a C-level leader or data expert shaping the future, you're in the right place.
I'm your host, Mirko Peters. We explore how data science and AI drive real business impact straight from the leaders making it happen. Today, a single organizational discipline that separates experiments from reliable, repeatable AI at scale, treating features as products. In 23 minutes, I'll walk through an executive playbook, why features deserve product thinking, how to prioritize and fund feature platforms, architectural trade-offs, and the governance that keeps things both safe and fast. Why this matters now. As AI becomes routine across sales, operations, risk, and customer journeys, the messy reality is models fail less because of algorithms and more because of brittle, duplicated inputs. Features, the engineered inputs fed to models, are the single highest leverage asset you can make reusable. When you productize them, you reduce duplication, improve consistency, and measure impact directly. That's where models turn into measurable value. To ground this conversation, I want to introduce a representative profile you'll hear throughout this episode, a chief data officer at a Fortune-scale firm who led the move from ad hoc feature engineering to a company-wide feature platform. I'll summarize their charter and choices so you get a practical, executive-grade example. We were responsible for a data estate spanning 24 product teams and hundreds of models. Our charter? Reduce risk, speed delivery, and measure AI ROI. Early on, we saw the same features engineered 3 different ways in 3 different teams: duplicate work, inconsistent definitions, and models that broke when production data drifted. We decided to treat high-value features as products, discoverable, versioned, tested, and supported with SLAs. That shift wasn't purely technical. It was organizational, clear ownership, funding mechanisms, and a simple prioritization framework tied to business outcomes. The early wins made the case to scale. If you're an executive deciding whether to invest, think of features as durable assets that survive platform shifts and model upgrades. Let's go from strategy to execution. First question, how do you identify which features to productize? The short answer, prioritize by business value, reuse potential, and operational risk. Practically, start with a top-down inventory. Which features are used across multiple models or directly drive a revenue or risk metric? If a single feature touches 2 or more teams and affects an SLA or revenue line, it belongs in scope.
Use a 2x2. Impact versus reuse. High impact, high reuse features are immediate candidates. Medium reuse but high impact can be adopted fast if the engineering cost is low. Low impact, low reuse features stay in local teams. This reduces upfront investment and proves reuse before you scale the platform.
We productized roughly 10% of our features initially, the top decile by value and reuse. That small scope let us measure real ROI within 6 months and avoid overbuilding. It also gave us a repeatable pattern for the next wave.
Now, the architecture. Feature stores are a useful abstraction, but not a silver bullet. Think in 3 layers: feature definitions and lineage, offline feature computation for training, and online feature serving for inference. You need clear contracts between those layers, so teams can trust that the online value matches the offline feature used in training. Instrument lineage and versioning from day one. If you can't trace a feature back to its sources and transformation logic, you can't investigate drift or regressions quickly.
We built a minimal feature store, a catalog with metadata, lineage, and automated tests, plus an online serving layer with tight latency guarantees for production inference. For some features, we preferred vectorized, batch-computed values refreshed nightly. For others, sessions, fraud signals, we needed sub-second freshness. The engineering choices followed the SLA and cost trade-offs. Trade-offs matter. Online serving adds complexity and cost. If the business tolerates minute-level staleness, a nearline approach is cheaper and more robust. Also consider data quality and freshness decisions as product requirements. Each feature product must declare its freshness SLA, expected null rate, and fallback behavior. That becomes part of the consumer contract.
Instrumentation and feedback loops are essential. For productized features, you need production metrics, consumption counts, latency, error rates, drift indicators, and business-level impact tied to downstream model performance. Create dashboards that link a feature's degradation to business metrics, so stakeholders see the cost of failure in dollars, not logs. One concrete win. We standardized a customer lifetime value feature used across marketing and credit models. After productization, reuse eliminated duplicate ETL and aligned definitions. Time to market for new experiments dropped by 30%, and model stability improved. False positives in fraud-related models declined because everyone used the same tested LTV calculation. But we also had failures. One over-centralized feature team turned into a bottleneck because we tried to own too many features too fast. We learned to keep the scope tight and use federation. Which brings us to organizational models. There are 3 common patterns: centralized platform, federated product teams, and hybrid. Centralized gives consistency and economies of scale, but risks slow delivery. Federated preserves domain autonomy, but risks drift. Hybrid, central core platform with domain-aligned feature product owners, balances both. We adopted hybrid governance. A central platform team built the infrastructure and standards, while feature product owners lived in business domains. Funding came from a combination of platform budget and feature usage charges tied to consumption. KPIs included percent reuse, mean time to onboard a consumer, and business impact measurements assigned to feature owners. The SLA enforcement was lightweight: automated tests, lineage checks, and monthly review cycles. That kept agility high. On SLAs and contracts, make them practical. Declare freshness, expected availability, and acceptable error modes. For critical features, require automated rollbacks and fallbacks. For non-critical features, accept looser guarantees. The goal is to make expectations explicit so product teams can plan and engineers can architect appropriately.
Change management is cultural work. To reduce duplication, you must change incentives, reward reuse, bake feature discovery into onboarding, and require feature reviews in model governance. Small policy levers, like a reuse quota for new projects or minimal cost credits for using productized features, can nudge behavior fast. Looking ahead, feature productization will integrate tightly with model governance and composable AI. As models become more modular, trusted feature products become the glue that allows safe assembly of components. Expect vendor ecosystems to offer managed feature catalogs, but remember, product thinking and ownership are what drive long-term value, not the technology alone.
What should leaders prepare for in the next 12 to 24 months? First, invest in a minimal catalog with lineage and testing. Second, assign feature product owners in domains. Third, measure reuse and business impact as KPIs. Start small, prove reuse, then scale. Avoid over-investing in infrastructure before reuse has demonstrated.
Before we close, 2 actionable moves you can take this quarter. Prioritize roughly 10% of your features for productization, the top decile on impact and reuse, and assign a feature product owner for each. Make each product owner accountable for SLAs, instrumentation, and business impact.
My final reflection: features are durable assets. Treat them as products, and you convert engineering effort into sustained leverage. That's how you move from experimental models to dependable, measurable outcomes.
That's the difference between models and value. If you found this episode valuable, subscribe and share it with your network. And let's connect on LinkedIn. I'm Mirko Peters. We'll be back with more conversations on how data science and AI create real business impact. Until next time.
Thanks for listening to datascience.show. If you found value in this episode, subscribe, share it with your network, and join us next time as we explore how data science drives smarter decisions and better business outcomes.